Hello everyone, my name is Erfan Dejband and my deep learning project is about using deep learning to inverse design of metasurface structures. To this purpose, first I talk a little bit about what is metamaterial and metasurface. Then there is two different models. One of them is forward, that is using neural network instead of simulator softwares, and the second one is backward or inverse design that I show you two networks that use to help the designers to design the metasurface or metamaterial. So what's the metamaterial or metasurface? Meta in Greek means beyond or higher, so metamaterial means you create a material that its properties is change, and you cannot find this material in the nature. And these materials usually made by combination of metal and semiconductor. And metasurface is just 2D version of the metamaterial. So why we use neural network? Actually, because using simulator softwares like CST and HFSS to find the electromagnetic response of these materials is very time consuming. Here you can see a picture of electromagnetic response of a mobile phone. So if you want to simulate this, it takes maybe more than 10 minutes. But by using a neural network, it's possible to get the electromagnetic response of these materials less than a second. So in this project, I created just a simple structure with it made from 3 different bar with different lengths, and each bar have different material properties. So we have 6 important parameters for designing this structure. Then after we design this structure in the CST environment, we run the simulation and we can get the electromagnetic response, but it takes a lot of time. So we collect the data by changing these parameters, and in the next step we use this data for our neural network. So after that we can get any other simulation result with neural network in less than a second. So there is different way to convert this plot to the data that is usable for neural network. You can use 2D convolution or other methods. Here I simply just choose 40 sample and stack them. So I produce about 5,000 data, and I separate 20 of them for testing and 10% of the remaining data for validation. So here it's my network configuration. I have 4 hidden layers, and each layer 215 network neuron. And here you can see that design parameters assume it as input, and the electromagnetic response assume it as output, and it's a kind of regression problem. So after training the network, you can see the loss and accuracy of the network is pretty good, but the accuracy can be better if you produce more data. And here is my code, and I save this model as forward model because later I need this. And here you can see several results. For example, if I give these 6 parameter, these 6 values to the neural network and ask the neural network what's my electromagnetic response, the neural network give me this orange line, And in the reality, if you simulate this value with the simulator softwares, you will get the blue line, so you can see results are not bad. The point is that if you simulate it with the simulator software, it takes a lot of time to you. For example, I think 3 to 4 minutes, but here you can get the result less than a millisecond. Here also is two other results. Sometimes that you have a loss of fluctuation, it will be hard for network to predict it very accurately. So let's go to the second part, is inverse design of structure. It means that we want to have this electromagnetic response as this plot, but we don't know what's the best value for our design parameter. So we can train a neural network like this, that we consider this as our input and consider the parameter value as output. I did this, but there is a problem here. This is my code and this is my network, same as before, 4 hidden layer with 215 neuron. Just the input, just I changed the input and output, so this time input is electromagnetic response and output is our parameter. But there is a problem because the the answer for one electromagnetic response is not unique. Maybe you have more than 2 or 3 answers. So here you can see when I tell the neural network I want this blue line and what is the best parameter, it gives me this 6 value. So when I give this 6 value to CSC and design the structure, I will get this orange plot, and this is not good. So one method to overcome this issue is that using the following structure for a neural network. I find it in a paper here in reference 1. You can see it is pretty interesting, that you can give the electromagnetic response as the input and compare it with itself as the output. And this is nothing else but our previous forward model. And here in the middle, we can get the best value for our structure. So I did this as we learn in deep learning course. I choose about 6 hidden layer, yes, and I add my forward model and make the trainability to the false. So here you can see I have about 200,000 non-trainable parameters, and here you can see this part of the network is related to this green neurons, that is for inverse design the structure, and this function down here is for the forward model, that the weights will not count for trainable weight. So after I train this model, you can see the result become much better. This time when I say I want this blue line, the network give me this 6 value, and after I use this 6 value to in the CST and design my model, I get orange line, which is much similar than what I want. And thank you very much for your time and concentration.